Morning. We close the chapter, open a new one. Chapter 8. We're starting functions. Okay? So I know rational equations, rational expressions were a kind of nightmare for some of you, but this chapter comes as a relief for a couple of weeks before we go into chapter 9, which is radicals. It's another tough topic. So this is kind of easier topic. I mean, kind of good break from tough calculations, but that doesn't mean we need to relax and skip working homework now. Still, there are some parts you need to pay attention. They are extremely important. Just because it's kind of easier chapter doesn't mean we don't use it. We use pretty much everywhere. Functions is what we are going to cover here. Functions is kind of a fundamental of math, so you'll learn it now and you'll keep using it. Pretty much actually everything is that way in this course. We are building our fundamentals for the college algebra next course. But functions is a must, is a staple concept. But before learning the functions, we will start with learning relations. So what is the relation? What is a relation? So I want you to first read and take a look at this example. Just think about it for a second. I need to reopen this file. Okay, relations happen in our everyday life. You can pretty much relate a pair of numbers, two numbers. You can group them and relate, like your age and height, okay? Or your speed and braking distance. The faster your speed, the brake distance will be longer. Your package weight and shipment fee. For example, if you're sending a letter, they measure it and assign a value to it, right? So in human life, for example, physiology, length of femur bone is related to height of the person. What is a femur bone? It's just a large bone between your thigh and knee, okay? And it's measured in some person 45, and the person's height is 65 inch and 48 into 68 inch. So some people have shorter, although they are long, but some people have longer. But you can relate those two numbers. This goes into your chart, okay? Your height and your length of the bone, okay? So we pair them up and put it in parentheses. This is the basic setup. And separate with a comma. This is the first number. This is the second number. But you know, in math, this is called x-coordinate. We will call it x-coordinate. This is the y-coordinate, because you can really plot this data on x-y coordinates and show that as a dot. It occupies a dot space on that grid paper. All right. So relations are nothing but list of pair of numbers put inside a parentheses. So this entire list, 1, 2, 3, 4, 5 pair of numbers, is called a relation. So they are really very loose terminology. You can pretty much call anything a relation. Does it have to be numbers, by the way? No. It can be words, like, okay, like 3 green, sun yellow, sea blue. What is the relation here? Some objects with their color, for example. You can create relations between words as well. It doesn't have to be numbers, but in math, of course, we deal with numbers, not words. Okay? So what are we going to first learn about them? We are going to learn two names or concepts, terminology: domain and range. How many of you guys heard these words before? Domain and range. Okay, we're gonna find them. What is domain then? Domain is the list of, it's just a list, like your shopping list. You put a list of record of things. Where do they happen? They happen on the first coordinate. You keep recording numbers that's mentioned in the first coordinate, such as these guys in the first coordinate, right? And you make a brand new list of them, and with a comma, separate them with a comma, 45.5, comma, 48.2, comma, 41.8, comma, make an entire list and put that list in these curly set parentheses like that. That's what we call domain. So actually the example that listed already, you put all the numbers in the first coordinates you observe and put it right here. That's called domain, set of first components. What is range then? Range is the list of all numbers in the second components, or y values. It's the list of all y values. Okay? Well, there is a string attached. There is a clause. No repetition is allowed. Sometimes a number shows up in two different spots, like 45.5, and another 45.5 shows up here, because two different people can have the same femur bone size. Then we don't repeat it twice, just you record it once. Just list of classes. You take biology, you take math, but we don't make a separate list in registrar's office. You have your single person, you have a single OSU ID, okay? So like that, your name is mentioned only once in domain and range questions. Any questions so far? So let's find our first domain and range problem. Question number 1. Here is your list, like bone size, your height. Bone size, your height given here, just like imagine like that. We are going to first list the relation. Part A is, what relation do you see and can you list it in the proper mathematical notation? This is the proper mathematical notation. You start with two curly parentheses, set parentheses, and you pair each row and column into parentheses. How many parentheses do I need? How many sets? 1, 2, 3, 4, 5. I see 5 pairs here. I need 5 parentheses. Column 1, column 2 goes accordingly. Column 1, column 2, minus 4, minus 2, minus 4, 4/3, 0, negative 7, negative 8, 2. Any questions? You pair, you can even pair first here, then move it there if you want. Okay. Alright. This is how you're supposed to type in. I'm not gonna type in the entire list, but again, parentheses. They already have the curly parentheses for you, so you don't have to worry about that. 6, comma, to make a ratio again, you hit this 4, 3, and close parentheses, comma, -4, -2, etc., etc. Okay.
So what would you do for 4/3? You said you didn't want to repeat it.
Oh no, not in domain. When you're writing domain or range, we don't repeat it. Okay, I know this is gonna be wrong because I didn't type in everything, but in the second part, we're gonna write domain next. Alright, here is the entire list. Domain is the set of all numbers in the first component, or in x values. compile this list for x values. It's gonna be, what is the first x? 6. The second one is, and then another one, right? Am I right? No repetition is allowed. So back up this one, wrong. I already counted that in, so don't repeat. 0 is next and -8 last. Alright, the tradition is to order these numbers from smallest to biggest. I believe this is accepted. I will test it. But the tradition is to check any repetition. Healthy way is, if you line them up from smallest to biggest, you see the repetition, so you avoid making mistakes if you line up from smallest to biggest. But I think any order is fine for this matter. 6, -4 is 0, and oh, I'm not typing. Okay, thank you. 6, -4, 0, and -8. Okay, so we're good with any order, but again, if you possible, line them, reorder them in the ascending order, smallest number to biggest. Alright, for range, you pick the numbers in the second component without repetition. So I have 4/3 already here, and I have -2 coming up. Well, another 4/3 coming up. Are we gonna repeat that? No, we don't. We skip that one and go to -7. Again, it's a good idea if you reorder this from smallest number to biggest, like -7 is the smallest. It should be first, and then 2. Okay? This is called domain and range finding. We did it in relations, but guess what? We're gonna do it on functions as well. So it's a really major thing, finding domain and range. So you guys pay attention, alright? Let me know if you have any questions. Any questions? Okay, this time we have a relation between names and numbers. This is not a typical math question. Okay, this is a real life application of relations. Such as, what is this relation? It's states. On the left side, in the domain, I see some state names. X values are state names. And the way they are founded, or statehood, they become statehood in 1820 Maine, 1889 Washington. Okay? So we first construct our relation in official terms. This is what official relation notation is. You put every pair of things in parentheses. Again, we have 5. I will just list it quickly, but I'm not gonna type in. It's gonna take a while. Alright, so first one is, what is the first pair? Maine 1820, Kansas 1861, Utah 1896, Montana 1889, Washington 1889. You get it? You just pair up. Or what is the domain? Domain is Maine, Utah, Montana, and Washington. Okay? And range is all those numbers: 1820, 61, 96, 1889, and 1889. Right? Yeah. The last number is tricky. You repeated it, so you don't repeat though. Only 4 terms in the range. No repetition allowed. Okay? Oh, they already have the list here, so great. You just choose the one that seems right. Which one is it? The last one? What's wrong with the middle one? Oh, they have the second one, Montana 1861. I don't see that. Okay. So they kind of reordered it somehow to trick you, but the main is all those names. The first one? What's wrong with the first? Arkansas is not in the list. Okay. Yeah. Alright, you need to type this in. I'm skipping because they're easy, okay? But let me know. Alright? Any questions? Good? Alright, what is this? All of a sudden, instead of rows and columns, we switched to two circular shapes and arrows between them. What the heck, right? Now it speaks the same thing actually. It's just a different view. If you want, you can switch from this to table if you like it this better. How? How do you read this off? You put X on the left and Y on the right. Look, they have the same X and Y here. You line these numbers on the left. How many rows? 1, 2, 3, 4 rows. 10, 20, 30, and 40 to the left. And what do I put on the right? Oh, you have only 2, so I just put them here like that? No, 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 this is not how you do it. You follow the arrows that relates each number, and that helps us figure out the associated number next to each number. 10, watch out where 10 goes. 10 goes to 15. 20 goes where? Follow 12. Oh, 30 goes and 40 goes 12 as well. These are all 12. So when you're writing your relation, by the way, sometimes they call relations by capital R this, you pay attention to these pairs. Don't just list these 6 numbers here. You pair up 10, 15, 20, 12, 30, 12, 40, 12. But when you're writing domain, when you're writing relation, this is superior. This is really great to have on the side when you're writing relation. But when you're writing domain, this picture is much better because this is domain. Just take these numbers in here, and this is your range. And take that numbers down here. So the domain is 10, 20, 30, 40. Range is, what is the range? 12 and 15 only. Don't use this table for range because there is repetition here, but this is safe. No repetition on this one. Okay? So relations are coupler. They make couples. They take somebody from the left, somebody else from the right. They make a couple between them. That's it. That's a relation. Are we good? All right. Now, we have already seen 2 notations. First, listing option. We list each and every couple one by one, separated with a comma. We have seen, this is called, by the way, technical name for these pictures is called Venn diagrams. The guy called Venn first used them, diagrams. This is called Venn diagrams. And we literally show that relation with arrows, really. Couples are linked to each other with arrows. And the third type, this is first, this is second option to represent your relations or show your relations. The third one we use is graphs, graph papers. There are 2 versions here given, one on the top, one on the bottom. What is graph versions? You literally plot points if there are countable points. 1, 2, how many points you count here? 4. If your points are handful, you can count them one by one. It's limited number of points. You can plot them and show with a color to readers. But sometimes there are so many dots You can't count, because every time you mark a point here, it has x and y coordinate, x and y coordinate. They need it to be represented by equations. Again, they produce graphs. This is your relation, graph of the relation, but it's a solid curve now. It's connected. And every time you stop somewhere, you have a pair of numbers, such as 1, negative 1, 1.5, negative 1.5, 2.03, 1.89. Millions and billions numbers are listed here. Take a magnifying light microscope and look at it deeper and deeper, you get another pair of numbers. So you cannot list them one by one. So this is dead. You can't list them one by one. Alright? You cannot do this Venn diagram because there are billions of options. How are you going to fit them in here, right? One by one. So we need to sometimes represent relations with equations. Because here I see billions of numbers. Every time I put a number here and another number there, I'm creating one. As long as you have a pair that satisfies this equation, you have a pair of a couple of numbers in the relation. Okay? So how many different ways of relations are shown? List, Venn diagram for finite options. Dots, again, a finite option. Graph, but if you have so many numbers, we use solid connected curve or lines or equations. Okay, now we're going to now do what we did earlier, find domain and range, and also list all relation terms by looking at this graph paper and dots on it. Okay, so in part A, you're gonna list all those numbers you see here. How many numbers do you see? How many pairs do you see? 1, 2, 3, 4, 5. So you need to make 5 of these guys. And how do I get those numbers? You just need to hit X and Y and read them. So this is -4 and 1, right? Correct? -4, 1. The next one is, anyone? 1, -2. Third one, 2, 3. Next one. Oh, by the way, you can also put those numbers next to the point. So this is 1, 2, 3, 4. What is that? I don't see anything for Y. It is 0. This is 4 again. It has the X component same, but Y component is -4. 4, 0, 4, -4. Alright, what is the domain? Okay, this is positive 4. What is domain? Anyone? -4, 1, 2, 4. Right? Don't repeat. Range. 1, -2, 3, 0, -4. Again, it's a lot healthier if you order them from smallest to biggest so you can avoid repetition. Did I get it right? This one? This one? Yeah. Thank you. Okay? And you know how to enter these. So I'm not trying on Connect Math. Alright, now here comes the challenge. You don't have just 5 dots to list here. You have 1 billion of them. How do you list all of them? How do you list all these? We can't. That's why they're not asking for it. They're not asking list all the relation. We cannot because there are so many. But they could have asked this. Write the equation of the relation. This curve has an equation which you don't know. It's called an ellipse equation. You'll probably know it in the next college algebra class. But right now you don't know it. You can't put it down. They're not asking. Okay. Domain, however, yes, you can do that. You can list domain. I will show you how first on this one. Look, how did we discover domain here? We just listed all one by one, and you just circled the first digits. But I want to show you an alternative way. That's what you're going to do in the next question as well. All you need to do is take a giant what is that? Okay, you don't buy it. I was trying to show a base of a foot, shoe base, but yeah. All right. Why don't you take a giant heavy metal plate and really from both sides smash those points with these heavy metal machine compresses all those points up and down. What happens? Where do these points fall into? Smash it to x-axis, right in the middle x-axis. This point is gonna fall here. This point is gonna fall there. This point is gonna fall here. This point is gonna stay in place, and this one will fall on top of this guy, right? I'll write these numbers. What is this one? -4, 1, 2, 4. Oh my god, it's the same as this one. That's how you find domain. You smash up and down and see the image on x-axis. Alright, do it here. Take two giant metals, smash this egg. This is an egg. At home, go home and take two metal plates and smash your egg. Alright, don't do that. It's messy. What is the image gonna be? This point is gonna stay there. You're smashing it down and up, right? This point is gonna stay there. What's gonna happen to everything in between? This point is gonna fall here. That point is gonna fall there. So they will make this. And some point before will make that. So all these points, blue points above, this is a blue point, is gonna fall and smashed onto X here, right? And are we going to have spaces like this between them? No, it's going to be a connected green slime here. Blood of this circle or ellipse. Green slime is gonna be on the floor when you smash it. All you need to do is read this green stain on the carpet. It extends from here to here. Write it not as a list. You cannot list one by one. You cannot say, oh, -4, -3, -2. Yeah, I see here -4, -3, -2. Well, how do you count everything in between? Well, how about the numbers between -4 and -3? Right? No. I mean, even unions won't save us. It's called, look, interval notation. Do you guys remember interval notation? This is a piece of line. A piece of line starting at -4 and ending at 4 and everything between. How do you write this in interval notation? Interval notations are these: either both parentheses, both brackets, one parenthesis, one bracket, left side bracket, right side parenthesis. You need to pick one. Bracket means endpoints included. ends included, left end included, right end included, right end included, left end included. So are we gonna include endpoints here, -4 and +4? Do we have a dot there? Really filled in dot? Yes. So we need to go with this option. What is the endpoints? What are they? Where does this stain start? When? -4. When does it end? +4. Okay? That's domain. Guess how I'm gonna find range? Let's see. Who can use this idea to find range? This is domain, so I'm going to clean this up. 2 metal plates smashing up and down my egg, these eggs, okay? And I get a stain on the floor and I read it. That's how domain is done. How do you do range? Opposite direction, sideways, we now smash with these plates. Smash this side and smash that side with metal plates. And these points now, let me mark a couple of values. These points will start falling to the y-axis. They will be pushed against y-axis and the slime stain is gonna happen on y. So this point is gonna make this stain, this point is gonna make, and this point is gonna make the same stains. This one is here, that, and that, and that, and eventually, oh, when everything collapses, this is what you're gonna get. Alright, who can read this interval now? That's called range. It's set of all y values. Look, it happened on y. Second component, it is it's here and between these two. So I see 2 on the top, -2 on the bottom. So 2, -2. We're done. Agree? Agree? You shouldn't be agreeing. What's wrong? Yes, when you're reading range, you read from bottom to top, which is -2 first, +2 right. When you're reading domain, you read left to right. You read the left side first, right side next. Important, okay? Just because you see this first doesn't mean that comes first. You read from bottom to top in increasing order. -2 is smaller than 2, right? Make sense? Let's see how we enter this. You already entered intervals before, so it shouldn't be difficult. Yeah, you just make brackets with your keyboard, -4 and then 4. Same deal with y-axis, range values, okay? Alright. Getting harder and harder. This time it's a roller coaster. Going up, you first go up and then go dive and then go up again and stop. Alright, why don't you guys give it a try on your own? You know what to do. Take 2 metal plates and smash it. 1 minute. Okay, I first compress it horizontally or vertically, up and down, smash. And I see this point is smashed right on that location. It didn't even have a chance to escape. We got it right on the spot. The guy above it comes next to it, and everything up above comes next and stain on the carpet. And then some guys from downstairs coming and joining them. And finally, this is the end of the stain. So let's read it. What is this point? Again, this is a included point. That's an included point. So whatever these 2 points are should be included. So I see -4 and 2. Since they need to be included filled in dots, no holes there, I'm gonna go with this as domain. About range, you didn't get the credit yet. About range, we smash this term horizontally from the sides. Again, these are plates squeezing in, and I see this point going the maximum here. The highest stain will be result of this point, and then double points, every point start falling under it until the minimum value of the stain is gonna be right here. And they helped us giving these locations. I mean, they didn't just put this for fun. They want us to read these values from these components. 2, 4 and negative 2, 4 is these values. Negative 2, 4, and this is 2, 4. Negative to positive. Seems like this is correct. So it's the right answer is second one. Okay. So here. Okay. Are we good? And the final question. This is kind of fun. I mean, it has nothing to do with smashing anymore. It just have many parts. But you're gonna answer it by looking at this table. There is a relation here. What is this relation about? This is a relation between month of the year and the precipitation. Average precipitation in each month. In where? Florida. Miami, Florida. In January you get 2.01, February 208, etc., etc., all 12 months. They're asking what is the range element corresponding to January? Anyone? Part A? Yep, you read January 2.01. What is the range element for April? Which element in domain corresponds to the least value in the range? You're gonna find the least value in the range and figure out what month corresponds to that. What's the least amount? When you get the least rain or precipitation? December. So this is least. So which month is it happening? December. Alright, complete the order pair. Which month corresponds to 6/21? May. November, what is the precipitation in November? Alright. What is the domain of this relation? January, February, March, April, May, June. This is not repetition, that's why I wrote June, July, etc., etc. You got it, right? All months. Alright, so you can officially read tables or relations, okay? That's the purpose of this activity. Do you want to take a quiz? Yeah, let's take a quiz. It's good for you. It's the more chances you get, the more points you. Even you get 0, you're not penalized, because every point you collect goes to your bucket. You need to get 910. So even you miss it, you're not at jeopardy. Okay. There is no percentages in this class. Every point works. Okay. And again, you either get full or no credit, because it's kind of bonus.
So you just want the range in the domain?
No, I didn't pick the question yet.